So I get 15 minutes to explain the global impact of all of AI, a topic that I normally explain in like 1,000-page book. So we're going to have to go fast. And I think the best way to think about it is to start with an analogy. And if we ask, what's the global impact of the internal combustion engine? Well, one answer would be it's huge. It's like 9% of the GDP. Another answer would be, yeah, but it also has some negative impacts of pollution and accidents and so on. And then a third answer would be, it's a great industry and it does a lot, but look at all the things that it relies on that wouldn't work if they weren't there. We need public roads, we need inventions of lots of other things like rubber pneumatic tires and seatbelts and so on. We need a huge network of gas stations spread around, or now charging stations. And we need driver education classes so that the masses know how to do it, so that we don't need a chauffeur for every car. So think of AI as being the same as that in many, many ways. Currently, it's something like maybe 1% of GDP, depending on what you count. But many people are predicting that the impact, not the AI industry itself, but the impact of AI in all the other industries could be around 10% of GDP, not too far in the future. And of course, AI does rely on a lot of infrastructure that we built up over the decades. We had to go out and collect a lot of data in order to do that. What do we do? Well, one thing is we developed sensors that are much better than they used to be. So everybody has a cool digital camera now that they carry in their pocket and they use all the time. The sensors on the self-driving cars and so on get much better. And we built this gigantic network to connect all the people, to allow them not only to be consumers of this data, but also producers of it. People are writing things all the time, and we learn from that. And another aspect of the network is that it forms a distribution channel and a marketplace. And many of the applications of AI are not things that people would pay for on their own, right? I would never pay to say, will you give me a recommendation for customers who bought this also bought that, right? That's not something I'm going to subscribe to and pay on my own. But if the network's already there, then there's lots of opportunities for that type of add-on. Of course, we needed all the computer science advances, database administration, and so on. So long before there was AI, we were setting up all the tools that made AI possible. And we needed these tremendous gains in computational power. I remember some of the experiments I did back in grad school in the 1980s, where we tried something like we tried this neural net and ran it overnight, ran it the second day and the third day, and didn't get the answer. So we gave up and I said, I guess neural nets are no good. And we went on to other technologies. Well, now that 3-day computation would take about 1 minute. And maybe it would have actually worked and we would have changed our whole emphasis. So that's in terms of where the industry came from and what we needed to get where we are. What can we do with it? Well, one thing I think is important is AI changes the way that we make software. So the traditional way in which we make software is we get an idea, we tell the computer step by step, this is how you do it. And I have to know exactly everything. In situation X, I do Y, and I have to work that all out. It's logical and Boolean, and it's telling it exactly how to do it. It's basically I'm being a micromanager. Everybody hates micromanagers, but that's what a programmer is to the computer. Fortunately, the computers don't get too mad about it. And it's a mathematical approach. It's, in the limit, we kind of prove our program's correct. We never actually do that in real life, but that's what we're aiming for. With AI, it's completely different. Instead of telling the computer how to do it step by step, we tell the computer what we want it to do. We say, this is what we're trying to optimize, and I'm not going to instruct you how to do it. I'm going to teach you and help you get there by showing you examples. And then the computer will figure out how to get there from those examples. So that makes it an experimental rather than a mathematical. It's an empirical science. Uses probability and statistics rather than Boolean logic. It really changes everything about the way the software development process works. We haven't got to the point quite yet where that's permeated everything that we do, but we're going in that direction. While we're on that route, we find that the companies have a lot of misconceptions about how this will all work, right? So they understand the basic process of we collect some data, we feed it into this complicated machine learning algorithm, it produces some outputs, and if they're good, then that goes into our product, and at the end, success and profit. And companies are scared and say, well, this part in the middle with the machine learning, that looks hard because there's all these math equations with calculus and derivatives in them. And that's where I'm going to spend all my time trying to get that right. And after they do it a couple of times, they realize, you know what? That part in the middle was the easy part. And the hard part was wrangling all the data and making sure the data was valid and making sure it was updated and building the entire system around it. And so that's a change in expectation, and I think it'll be a change in emphasis. So we're turning out all these PhDs in machine learning who are focused on this mathematical part in the middle. That's not what we really need if we want to affect industries everywhere. In Cassie Kasparov's neat analogy, she says, it's as if I was running a restaurant and I said, my goal is to serve great food to the people. Who should I hire? I'm going to go out and hire a PhD in stove engineering so they can build a great stove, and then everything will be great. And yeah, we are kind of at the point where you do need to know something about stoves, but really you want to hire a great chef who can just buy a stove, install it, and get to work. Now, I guess going back to the automobile analogy, we're kind of at the point where you do have to know something, right? So in the early days of automobiles, they broke down all the time. You had to be a little bit of your own mechanic. You had to wind the crank at the beginning to get it started. Now everything's automated. And in AI, we're making that transition from having to know how to be the stove engineer to just knowing how to be the chef. And once we do, it'll open up a lot more even than what we're seeing now. So where are we seeing the impact? In lots of industries. I think one way to think about it is anywhere that you can detect a pattern of something that happens repeatedly that maybe people were doing in the past, or maybe you weren't able to do at all. But if there's a repeated pattern, then you can expect that an AI system can learn. And so we're seeing great impact in lots of industries, health industry, of course, in a couple of ways. One, just managing all these health records, which have historically been a mess. Another in specific things like reading radiology images. It turns out that our computer vision techniques are better than doctors at looking at that. So big impact in healthcare, in energy, in agriculture, in call centers, customer relationship management, tech support, and so on. That may all be automated or at least help quite a bit. In retail, you guys are interested in banking and financial services and insurance. We're seeing a big impact there. I think it's interesting that in some ways, the limit of machine learning technology means that there could be no insurance industry, right? Because machine learning is prior to doing predictions. And if I could predict exactly what your claims were going to be, then your insurance premium would be exactly the same as what you would have paid out of pocket anyway. So it wouldn't matter whether you bought insurance or not. We'll never get quite there because it's hard to predict, especially the future. And maybe the goal is more to segregate out the kind of random accidents and insure against that versus the more determined accidents of this person's a higher risk because of these factors. So we can go on to other industries, transportation. You'll see the big talk about self-driving cars and trucks and how that will disrupt industries and displace jobs. Manufacturing, we're starting to see the rise of robots. I think that will happen first in manufacturing before it happens in the home. I have a Roomba, but I don't really trust it to do very much. And I think it'll be a while. We'll see the robots work in more controlled environments, as you see on the factory floor, rather than in the homes, where every home is different. Okay, so with all this great technology, we also have new challenges. We have to deal with privacy and fairness and just figuring out what is it that we're trying to do. Because if we come in and we say we're no longer saying that programming is telling the computer what to do step by step, rather it's saying showing the computer examples and telling it to optimize what it is that I want. Now we have this new science of figuring out what is it that I want, and that's a challenge. And it's hard to do. And we've seen these examples of fairness type things where we say, what would be fair when we're doing like bail cases and recidivism? And one measure of fairness is calibration, to say, if I give you a score of 6 out of 10, that means that you're 60% likely to recommit a crime. And if that's true equally of black and white people, then we say that that algorithm is balanced. So we saw a company that says, I must be fair because I met that test. Very well balanced on that criteria. There's another criteria of calibration that says, when you make a mistake, who are you more likely to affect? And on that score, they're twice as likely to make a mistake that negatively affects a black person rather than a white. So now you have critics saying you're being incredibly biased and unfair, and you have defenders saying, well, on this other metric, I'm being exactly fair. And so as a society, we now have to decide, what does fairness mean? Because before we all kind of vague. Now it's implemented in algorithms, and it's up to us to make those decisions. So it's not just the mathematicians, not just the programmers, it's we as a society saying, what is it that we're aiming for? We all have to work on that. Thank you.